All right. You see my screen, right?
Hmm.
All right. So we're looking at assignment two, right?
Yep.
All right. Here we go. Cool. All right. So one of the things that we want to do, I want to walk through the whole assignment. Well, kind of get an idea of this whole assignment. And then we're going to review as we go forward on what you've already know. So you can start solving different chunks because you now we just moved from the first assignment that you've done, and it was fun and challenging. Now we're going to get bigger. The assignments are going to get bigger and a little bit more detailed, and
Hmm.
using more of what you've already learned: how to use your objects, how to use your functions, how to use your arrays. Yeah, and understand that objects and arrays are your data structures. And one of the things that's important is to understand how data structures work. As a matter of fact, they call it the big O notation. And let me kind of introduce that to you real quick. So, so I'm gonna call it the big O notation. And so let's just kind of hit on this a little bit. Because this is something you kind of might want to tap into.
Hmm.
And in the big O notation, what is the big O notation and why does it matter? The big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. It is a member of a family of notations invented by Paul Bachmann, Edmund Landau, and others, collectively called Bachmann-Landau notations, or a symptomatic notation. I can't even say the word. A symptomatic notation. And Wikipedia has a good definition. And let's see the Wikipedia. Let's go to Wikipedia. All right, so big O notation is the math. It says the same thing that we just read from the example of the article that the person wrote, but I always like to go with something a little bit more of a standard. And it says in computer science, big O notation is used to classify algorithms according to how their runtime or space requirements grow as the input size grow. So this is something we call space and time complexity. So
Hmm.
an algorithm and your functions and everything, they're written at a space and time complexity. And it always want to go to the worst case complexity. And what space and time means is how big it can get and how long it takes.
Okay.
The bigger it can get, the longer it can take, and it's broken down on a scale. And so with the big O notation, let me see if I can see something here. Like we got right here, this O of n squared. I'm gonna show you this O of n squared in our assignment, how we get to O of n squared because of how we wrote this particular function. And this is what we call the worst case scenario. O of n is a longer time and space complexity. It takes longer to iterate, and we're going to find out what's up O of n complexity because we actually have a nested for loop. You see that a lot in nested for loops. So I just kind of want to introduce you that for a little bit. Go ahead and read this article, check out the link
Hmm.
right here, big O notation, or Google it and check it out. So I just want to introduce that to you because we need to deal with data structures. And so,
Hmm.
like I said, objects and functions are objects as well. Everything in JavaScript is an object, except what's the only thing that's not an object, since you're the only one
Primitive data
online.
types.
There we go. And do you remember why?
um, because they are immutable.
That's one.
They cannot be changed.
Uh-huh.
I don't remember the second reason.
But they don't have properties nor
Oh, they don't have
object
properties or
properties or
methods.
methods. That's it.
Yes, that's it.
And we've kind of learned why now, since you got introduced to objects, actual objects, as the data structure, is that they have properties, key
Properties.
value pairs, and then they have methods that are functions. Now, remember, this is just a little rule that you need to understand. JavaScript has functions and methods. Java doesn't have functions. They only have methods. So that's the difference also when we get into Java. But I just want to let y'all know that, because when you're new, you'll start calling methods functions in Java, and you get a Java developer that truly understands Java, they will correct you. All right, so let's begin here. So we're in assignment 2, the Scrabble score. For your second assignment, we'll ask you to modify and improve our Scrabble score program. Did you think we were going to work on Mars rover code already? That will come next. That's assignment 3. We want you to update our program that asks a user for a word and outputs a score. Your final version will have 3 scoring algorithms and allow a user to interactively choose which algorithm to use. We provided some starter code that includes the official Scrabble scoring point system, and we like you to make some modifications to improve it. So let's roll. So here's the requirements. Note, the requirements below are what your assignment should look like when it's time to submit. Rome wasn't built in a day, neither was Scrabble. Now, let's understand something here, because it's so easy to gloss over a lot of information. What we're saying here is this is a process. We're basically refactoring the code that we've already given you, and you're making improvements to it. So that's what you're learning here. But we want you to take it one step at a time. Write some code, get it to work, then move to the next piece. Don't try to build the whole entire thing and never run the code. That's when a lot of people have a lot of problems. And then that's a good example that you probably copying and pasting, because you're not really understanding what you're doing. You just saw something that somebody doing, you copied it, and you did the whole thing. You never took the time to understand it. It's so important to practice, practice, practice. Practice is going to help you improve. The more you practice, the more you improve. So this assignment is broken down so you can complete small pieces as you go. You need clear what I just said, small pieces as you go. You need to move sequentially, meaning in order, starting with part A below. You'll have a much more enjoyable time writing this program if you read this entire page before you even open the Replit. Now, since you're only one, I'm putting you on the spot. Did you read the whole page first, or did you hop right into that Replit?
I read the first half of the page, and then I jumped into a Replit.
Okay. Well, we're going to read this whole page first before we jump into this Replit. And you want to get into the routine of doing it. That's why whoever's watching this video, I always say, read the whole chapter first. If don't get stuck on one thing, read the whole thing, go through it at least, and so you can know what's there, because sometimes we may give you a little bit more understanding at the end of the chapter. Then go back and break it down. Because at least you made it through the whole entire chapter, instead of making it to the first section and you've been stuck on that first section for 2 weeks, and come to find out, if you would have went through the whole thing, you might have found the solution, or it would have enlightened you to be like, okay, they kind of talked about that at the end. Let me kind of focus on that. So here, remember, I always talk about the AC, your acceptance criteria. Your acceptance criteria have features. So all of these A, prompt A, all the way down to whatever the number letter is, those are going to be your features. And
Mhm.
you have to satisfy each feature before you move on. The story isn't complete, or the definition of done. It's not done until your program is completely finished, meaning you have tested it and it's working the way it's supposed to be working. And
Mhm.
done to you is turning in the assignment. So don't turn it in until it's done. So you
Mhm.
need to make sure it's working properly. All right. So here's a little couple of tips here. One, write an initial prompt. Function. Notice here the key word is a function. And how do we know that this is a function?
Open close parentheses at
There
the
we
end.
go. There we go. And so it's either a function or a method, but a
Mhm.
method is always chained to an object.
An
That's how I know
object.
it's a method. That's how I know it's a method.
Mhm.
If it's not chained to an object, it's a function. But
Okay.
if it's chained to an object, it's a method. So that means it got that dot notation.
Mhm.
So function that asks a user to input a word. Two, have the program return a score from the word using a old Scrabble scorer function. Three, add additional scoring algorithms. You're going to add additional scoring algorithms and store them in the scoring algorithms array. So we're going to be dealing with the array data structure here.
Mhm.
Now create a transfer form function, functions that takes in the old point structure object and returns a new point structure object. And how are we going to do that? We remember that we're going to have that new object, I'm thinking that it's going to return. So that means I'm going to be pushing some stuff from the old structure. It says function that takes in the old, it takes in that old, and then I want to make sure it returns the new. So that means that's going to be somewhere in my transform function. Use the run program. We got a taste of what the run program does. The run
Mhm.
program is in our index is what's being ran according to our program. It runs the program, and whatever is inside of that run function is going to run in order. It's going to go from top to bottom. It's going to call each function, and once each function is called, or if you throw some console.logs in there, but it's going to go in order. So we've already experienced that in our first assignment. So of course we got our starter code. We're not going to fork it yet because we want to go through and read the instructions.
Mhm.
You only need to pay attention to one file here, which is the Scrabble Squirrel.js. So make sure you're not in index.js. Like sometimes it's easy to do that because sometimes
Yeah.
when you fork it, it goes to that page first or to the actual module or file first. So within the JavaScript file, is still some more starter code that you do not need to touch. We'll point out what you should be modifying here to write your Scrabble score program. Hit the Replit Run button initially, and you'll see a message print to the console. And this is what's going to print to the console once we get to the actual Replit. Now, here's a tip. If you don't see this message printed and have exhausted your troubleshooting skills, reach out to your classmates or course staff ASAP so you can get started with the real coding. Now, you should have enough experience to kind of understand how to get this to work. But the more you try to figure it out, the more you're going to gain understanding. It is
Mhm.
so easy, and what happens is people get frustrated. They get frustrated so quick and they never try to solve because they try a couple of things and now they frustrated. All right, let me hurry up and get somebody else to help me. I've done
Mhm.
that. So I understand.
Mhm.
But it doesn't help you because it never helped me because it just makes the person that is trying to help you frustrated because you don't know how to articulate yourself. You're not able to explain to them what you've tried. All you're just
Yeah.
saying is it don't work. It don't work. Why does
Yeah.
this not working? Why am I getting this error? Well, understand what the error is saying And
Right.
then that's a clue. It gives you a clue. What you can do is highlight whatever the error is, copy it, paste it into your browser, into Google, and see what comes up for a solution, and
Mhm.
read and get an understanding of the error. And one of the biggest error people have a problem with is that type error. And the type error is normally because you're either doing something wrong. If you get the syntax error where it's showing you at the end of the whole assignment that you're missing something, is not at the end of it. It's really maybe you didn't put a closing curly brace, or
Curly brace.
you're right, you deleted one of your closing curly braces off one of your functions. Understand how that works for our assignments. And the more and more you get experience with these error messages, the faster you'll be able to solve your problem. And then eventually you won't make those errors. You won't make those simple mistakes because you,
Mhm.
you already have the experience. So I just want to throw that out there. So here's our instructions. Here's part A, the initial prompt. Now it's said, now we got to look at the instructions here. Modify provided initial prompt function. So we gave you this
Mhm.
function to modify. So you're modifying that. And this function to prompt the user to enter a word to score. So we're going to add that prompt here.
Mhm.
One of the things up here in this, to get total, write an initial prompt function to input the word. So 2, use the old Scrabble scorer function provided to score the word provided by the user. Print the results to the console. So it's letting me know we're going to do a console.log. We're going to print some of this stuff, right?
Mhm.
Or maybe we won't use a console.log because you don't have to have console.log to print. Or maybe you do.
Yeah.
Well, you can how you call that function. So think about that. Before you move on, be sure you're on the right track. At this point, your program should have an output like this. So you got the let's play, that's what's gonna pop up first. Prompting to user, let's play some Scrabble. And now you're gonna enter a word to score. So right here, we understand this from the last assignment. We're going to use that input. We're going to have
Input.
an input variable that's going to have that required readline sync. We got to know where we're going to put that. And remember, readline sync is a method that's
A method.
inside of an object.
An object.
And they except so when you do your console.log on input, it gives you this object with all these methods where it says function. So now you have experience because when we did our console.log of our object, whenever you put a method in there, it said it was a function. So
Mhm.
now you understand that readline sync is an object with a whole bunch of methods in it that you can use to add to your object. So here we know by looking at this example here, this output, that when I enter the word, I'm prompting the user and then I'm creating pineapple. So that means they typed in pineapple. That means that has to be stored in
Stored.
some type of variable. And
Mhm.
then that variable has some information that is going to connect to all of these points that you created inside another object. And
Mhm.
these, and I know it's an object because it's giving us some points. And then I know that we had key value pairs. Hey, good
Mhm.
morning, Chris. How you doing? All right. So here we go.
Morning, morning, morning.
All right. So now, and this is being recorded. So you can go back and listen to what we talked about before you got on. So here in part B, it says add and organize scoring algorithms. Your job here is to write two other scoring algorithms for the Scramble player. So here we go. We're going to write a simple score, define a function. So that means that's a function that
Mhm.
takes a word as a parameter. Remember, what is a parameter? What is a parameter?
It would be an argument that you're passing into.
It's not an argument.
It is. Ooh, is it an object that is part of that function?
Or yeah, it gives us a rule. It's basically, it's like it's a placeholder almost, because you have a parameter. A parameter is letting you know what it is expecting for that particular function. And you're going to give it a name that can also be used like a variable where you can store stuff in it. And we're going to go over that in the assignment to make sure y'all understand that. And it says, and returns a numerical score. Each letter within the word is worth 1 point. Then we have another function, vowel bonus score. Define a function that takes a word as a parameter and returns a score. Each vowel within the word is worth 3 points. And I think that's spelled wrong. Consonant is supposed to be consonant, right? Worth 1 point. Just right here. I'm like, that's misspelled. Gotta let them know. Unless I don't know how to spell. That's not how you spell consonant, right? It's consonant. It's supposed to be a consonant, right?
I think that's the way it is, right?
But how don't you spell? Yeah, don't you? That's how you spell consonant.
Yeah.
I just googled it. That's it.
Wow, then I can't spell. I'm like, that's how you spell consonant. For some, I can't spell. Okay, cool. Make each scoring algorithm case sensitive. You remember how to do that, right? We know that we have to use a method, but you got to know how to use it the right way and where to use it. That's key. So now, once you've written these scoring functions, organize all 3 of the scoring options into an array. So we're going to organize these into an array. Your program will use the scoring algorithms array, so that's what it's called, to retrieve information about the 3 scoring algorithms and convey that information to the user. So you understanding what this is saying here? It says once you've written, so up here we have a scoring algorithm. So we're creating these functions up here. We got 2 functions that we're creating. And then it's telling us right here, it says, once you've written these scoring functions, organize all 3 of the scoring options into an array. So that means we're putting these functions inside of an array. Is that what that means?
It means you're putting it inside an array, but they all are going to exist as objects within this array.
All right. So here we go. So it says the scoring algorithms array to retrieve information about the 3 scoring algorithms and convey that information to the user. So now the reason why we want to talk about understand data structures and why data structures is so important to really become a real efficient programmer is because when we're creating these data structures, we're creating these functions, these algorithms, we're writing algorithms is what we're doing. And these are the mathematical equations or whatever you want to call them, but we're creating algorithms and we're reusing these algorithms. That's what functions are for, so we can reuse certain things. So sometimes we have a helper function. What's the purpose of a helper function?
To break down larger, more complex functions into smaller bite-sized pieces.
Right.
You later call and use to solve a much larger problem.
And you're going to use that, and you need to understand it because, like, for instance, React is a library, and we have these things called hooks. Hooks are functions, basically. And what you do, and these are built into the programming, but I can build a custom hook. A custom hook is what we call a helper, like a helper function. Because, for instance, when we start writing programs and we start noticing that we're repeating ourselves. So that's where don't repeat yourself dry. Don't repeat yourself. The reason why you want to create a helper function is so that you don't keep writing the same logic for 3 different functions. You got 3 different functions, but they're using a lot of similar logic. So instead of writing 3 different functions with the similar logic, have a helper function with that logic and just use that helper function for each one of those functions that's using that certain type of logic. So this is why you, like you say, you want to break them down into smaller pieces. You want your function to just do one thing. And a helper function is going to help you do that one thing. That helper function is doing one thing. It's doing one thing that all 3 of your other functions need. Instead of putting all 3 of the same code in those 3 different functions, just write one helper function, use the helper function and all 3 of those codes to help it do the one thing that it should be doing. All right. So here, 1. Finish writing the scoring algorithms array. It should be populated with 3 objects. Okay, should be populated with 3 objects, 1 for each of the 3 scoring options. Each object should contain 3 keys: name, description, and scoring function. So here's the example. Examine the table for the information to store in name and description. The scoring function for each object should be the name of one of the 3 scoring algorithms already defined. So here's name, here's the description, here's the scoring function, and we're going to have something simple score, bonus vowels, Scrabble for the name. So these may be some variables right here. Each letter is worth 1 point. So these points are going to be our key value pair, right? We're going to use those in our key value pair. Then here's a function with the parameters for users input that returns a score, a function that returns a score based on the number of vowels and consonants, and users uses the old Scrabble score function. So we're going to be using that old Scrabble score, and then we're going to be converting that into the new Scrabble score. So 3, finish writing score prompt function so that the user can select which scoring algorithm to use when the program scores their word. This is where we may be thinking of a while loop, because we don't know what they're going to put in. Use the selected algorithm to determine the score for the word. So A, if the user enters 0, have the program output a score using the simple score. Here we go, simple score. If the user enters 1, use the vowel score function. Here it is right there. That's the name of it. And if the user enters 2, use the Scrabble score option right here. And then in the score prompt function should return the object the user has selected. So these are prompts again. So I'm going to be using my input, right? My input, somehow I'm going to be adding it to this score prompt, right? To input the user. And then I'm going to have to be able to put it out there for the select. That's going to be in a console log or wherever it's going to be in my prompt. It's going to be in the prompt them and ask them the question, which one you want to pick, 0, 1, or 2. If they hit one of those keys. And so remember, we should be thinking, how do I iterate over an object? I can't use a for loop. I can't, what kind of loop do I use? I use a what? A for?
For in.
There we go. That's how you iterate over the keys. So here's some tips. Your scoring algorithm structure now holds all the scoring information required for the program. To access a scoring object and its properties, use a combination of bracket notation and dot notation. Now here's some examples right here of how to use the bracket notation and the dot notation. And here's the output. Now let me ask you a question real quick to see if y'all understand this. Inside of an object, and when we declare, how do you declare an object?
Curly braces, right?
You can, but how do you declare it? You're initializing it. So how do I declare it? I got to declare and then initialize it. How do I declare an object? Just like how do you declare a variable?
You got to give it a name.
There we go. And you have to give it a keyword, right?
A keyword.
Yeah. Now remember, objects are stored in variables. So when I declare that object, it's called an object literal. Y'all remember that? Now, let me ask you the question. What's the difference between if I declare an object to be a const, can the properties be changed? Go by what you've been taught and understand. Can the properties be changed?
No.
Okay, why?
Because it's a constant, meaning that those values that are given and properties will always be that.
So what you're saying is I can't on the outside of it be like, okay, like for here, I have the scoring algorithms. I can't go scoring algorithms dot name and then assign a new name to it and change the name of that scoring algorithm. That's what you're saying. Yeah. You believe that too?
Yeah.
Okay. Well, let me explain something to you. That's not correct. This is where it gets confusing. Although the variable name of the object is a const, the properties can still be changed. So I can go algorithm. So if the name of the algorithm was whatever we give it, the name we ever give it, that you put in the initial object, I can change all of those properties. I can give them new values or values to those keys. The keys are the same, but the values can be change. So you got to remember that. Keep that in mind, that you can mutate, it's mutable. The properties inside of a const object can be changed. So I just wanted to make sure y'all understand it, because right now your mind is just focused on it's a const, it's a const, it's a const. So we got to get you to think outside the box a little bit. Yes, it is the variable, and that's why I think I'm going to teach, they're going to let me teach here in on one of the classes. I'm going to talk to Clark, because I want to teach about binary numbers and how it also works in memory. Your variables are stored in memory. The memory of it doesn't change. You can't change it because it's a const. But the properties inside the objects can be changed. And that's where the confusion comes in. And, you can play around with it when we do one just to show y'all, if we have some time, on how that works. So here, 4, we're going to call the score prompt inside the run program. So now this is going to be put inside of our run program, because remember, it's reading from top to bottom. So whatever's in that run program is what's going to be ran and be printed out to our console, so that the program asks the user for a scoring algorithm after prompting for a word. Use the scoring object return from score prompt to score the user's word and let the user know what score the word receives. And before you move forward, before you go to C, you want to test your code. This is your output here. You should be prompting the user, letting the introduction to the user, letting them know, let's play some Scrabble. Then it's going to prompt the user to enter a word to score. You type in a word. Now, which scoring algorithm would you like to use? It's going to ask another question before it does anything. And here's your prompts right here. This is what it's going to prompt out. And then it's going to say enter 0, 1, or 2. You're going to actually put this in some type of console.log or in your input when you put in your curly, or you may store that in a variable somewhere. You see what I'm saying? And then you're going to make a selection, and it's going to pick 1, 0, 1, or 2. And then it's going to print to the screen score for whatever this variable coconut was stored in, because you're going to, when you prompt the user, you're going to store that inside of a variable. So whatever variable that's stored in, that response is stored in, it's going to be a variable right here in some type of template literal. And then it's going to give the score, which would be inside that template literal. So whatever this is holding it in is going to be printed to the screen. So we're going to remember your training. Remember what you've learned so far. So now C, transform Scrabble scoring. Currently, the software contains the data structure below for the traditional Scrabble scoring program. Take a few moments to review how the old point structure object relates a point value to a letter. So no, we have an object here, old point structure. We have the key, which is 1, 2, 3, 4, 5, 8, and 10. These keys are actually considered the point. This is how we're going to know. So we have an array with all these consonants in it. Then we have an array, and these particular consonants get more points, and these particular consonants get even more points, and these particular consonants get even more points. And this is the old one, right? But now it said the keys of the old structure are the Scrabble points, and the values are arrays of letters. All letters. Yeah, and this has, I said consonant, but it has vowels in here. I'm sorry. But this one, these vowels are inside here. So all letters in the array have the Scrabble points value equal to the key. For example, A and R are worth 1, K is worth 5, and J is worth 8. So this is how we get this point value up here, because it depends on what point value you pick, right? So here, so it says to find the point value for a letter with the old format, the program must iterate over each key. You see that keyword in. So we need a for in loop. The old point structure, and then check if the letter is inside the array paired with that key. So I'm going to be thinking, I'm checking if, so I'm going to need a conditional. So you're going to be thinking conditional once you get to this point, and how to use that. Now, think about this for a second. The scoring action takes in letters in a word as input and outputs numerical values. So here you put in this word coconut. So that means each one of these letters have to be split somehow, right? In order to break down which letter will it fall in one of these keys. So that's something to think about, right? So you got to be able to break this string up. So it'll be able to compare it to what's in one of these keys. So that's why we're going to be that for in. So for in old point structure is this C in one of these keys. Can you find it for me? That's what that loop is good for. So here we go, where we at. So to find the point value letter within the old format program, must iterate over each key in the old point structure and then check if the letter is inside the array pair with that key. This search within a search is insufficient. So it's saying, it's letting you know this search within a search is inefficient. So here's a tip. Think about this for a second. The scoring action takes in letters in a word as input and outputs numerical point values. Okay. I'm thinking just from reading this, okay, I'm gonna have to do some conversion here. So let me see here. We can improve our program by rewriting the data structure to better fit the actions we want to take. Keep this idea in mind as you go on to code your own application. It would improve the performance of the program to create a new point structure object that has 26 keys, one for each letter. The value of each key will be the scramble point value. Okay, so we're going to be comparing and we need to be pushing stuff or getting stuff into that new object, right? Examples of the new key of key storage. A is worth 1 point, B is worth 3, C is worth 3, J is worth 8. Okay, how do we know this? Because we have the old point structure. It gave us the value of what each one is by the key. So we need 26 letters. Is it 26 letters here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Yep. So all 26 letters are there. So we need to create a new data structure object with all 26 keys. And we have to make sure we match up each one of these points to what we already have, right? So in the new point structure, the letters themselves are keys. All right. So the letters are the keys now. And so a single search will identify a point value. Once it hits that letter, we know that letter has a point. So it looks for the key. And then we know there's a point assigned to that key. Now, here's an example of the new point structure object usage. So we canceled out lost scramble score values for so A, and then new point value, and we put in the dot A. So A is the property getting to the new point object. So if A is signed 1, like I say, don't forget, if I can go ahead and change that dynamically by changing A to be another point if I add an assignment to it. So so that's something you could play around with just to see what I'm saying. That you can set that array up to be, or that object, new structure object, you can make it a const so you can understand how that works. So here's the console log output. So here's the output. Now we get down to transform the object. Write the rest of the transform function. It would need to take an object as a parameter. So now we're passing an object as a parameter inside the transform, inside the curly brace, not the parentheses. Inside the parentheses, there's going to be an object as a parameter, specifically the old structure. So it's going to be passed in here. And I think we already got it set up like that for you. So it's already set up for you. So we'll return an object with lowercase letters as keys. The value for each key will be the points assigned to that letter. Here's some tips. A, recall that for-in loops iterate over the keys within an object. B, if you need a reminder of how to assign new key values, review relevant sections in the objects and math chapters, because you want to go back and review. C, to access the letters array within old point structure, use bracket notations like this. Right there. Remember, we're passing in a string for the actual keys. But now remember, if this was an actual variable, we wouldn't need the quotes. So if you had a variable called key, you're passing in without the quotes. Another reason why you use brackets, most of the time we're going to use dot notation when we are dealing with objects. But one of the reasons why we use the bracket, because sometimes you may create a key string. like with multiple words in it. And in order to do that in an object, the key has to be in quotes in order to do that. So that's something else that you may want to play around with to understand. So a lot of the times we use the bracket notation. That's one of the reasons why you may use a bracket notation is because the key has a couple of words in it with spaces in it. It may have spaces in it. And so here we go. Or assign the array to a variable and use variable named index. So here we know that index, it could be it could be index, it's whatever, but notice what it says, array to a variable. We know that's a variable because it doesn't have the quotes. Here's an example. So we have the example right here. And we know that, and then this is an actual number. We don't put quotes around numbers, but this is a string. The string 4 with the number 2. So
in this case, 4 is the key.
Yes, 4 is the key, or as at least we know it's a string. So it could be the key. So the third letter within the key 4 array so it's actually the key 4, and the point value is 2. So the key is 4. The value is 2. So so if this was the letter A and we wanted to assign it a point of 1, then the key would have been A and the value would have been 1. All right. Makes sense? And so here we go. Here's the output. So it gives us the output right here. So in the key, you have an array of F, H, V, W, Y. And what we wanted was at index 2, 0, 1, 2, which is V. Yeah, so that's why we did it like that. So 2, locate the new point structure object in the starter code and set it equal to the transform old structure. Now, when we say equal, we mean assign. So I did to start a code and set it equal. And so, or maybe we could mean equal. It could be double equal. We'll see. So when I see equals, I'm thinking double equals or triple equals. But when you say set it, I'm like, okay, maybe that's what they mean. Set it equal means they may be talking about the double equal or the strictly equal. So here, hard coding the new structure object literal like this. So this is an object literal. This is the hard code of it. But it says won't pass and you'll lose an opportunity to practice this skill. So hard code the new point structure object like this. Won't pass and you'll lose an opportunity to practice the skill. So it wants to practice it, get in the habit of practicing it. Use your define new point structure. Use it to finish writing the Scrabble score function and then replace the old Scrabble scorer function and scoring algorithm with a new function. So you're going to replace it. You're going to get rid of the old one. And you're going to put the new one in there. Tip. Old Scrabble scorer uses old point structure and returns the score for each letter in a word. You'll want to write Scrabble score to use new point structure and return a cumulative score for the whole word entered. So that's why we get that right down here, this score. So test words. Here are some words you can use to test your score. We got JavaScript, Scrabble, and Zox. So we can test all of those to get our output. And then, of course, you pick each one of these to make sure all 3 of them are working, 0, 1, 2. Now, here's your bonus mission. Currently, the prompt accepts any input values. The user could enter something other than 0, 1, 2, 1, 0, 1, or 2 when selecting the scoring algorithm. And they could enter numbers or symbols when asked for a word. modify your code to reject invalid inputs, and then reprompt the users for the correct information. Now you can Google this on how to do that too, so you don't get stuck here. Google it. There's enough out there to show you how to make that work. In vanilla JavaScript. Score words spelled with blank tiles by adding an empty string to the new point structure object. The point value of a blank tile is 0. All right. So we did with the instructions. We satisfied our instruction. We wanted us to go through and read it first. We read it first. And so now let's go ahead and let's open it up. All right. So here we go. We're at the beginning. And now we have what we call the on line 3. Now we remember what line 3 is. So I've already ran it. Instead, that said, let's play. Let's play some Scrabble. And so if I go all the way down here to run program, that's the only function that's in there, the initial prompt. So it's just doing the initial prompt. So it says write an initial prompt function that asks a user to input a word. So I'm going to be in that initial prompt. Where is that initial prompt function at? Here we are, right here. Right now, all we have is the console.log. So now we need to add the initial prompt. So here's the initial prompt. It's going to be into a word. So it's going to go ahead and it's going to let's play some Scrabble. That's what we have right there. You know, I can go ahead and put a space in here if I want to, or I can put a new line break just so it can have some space to kind of look like that. So I got a little extra space and then another line break. Now I'm inside that function. Now, what I want to do is I want to write an initial prompt function that asks a user to input a word. So now let's look and see everything that we have at our disposal. We have some variables over here. We got a few variables right here, and we have one function that's already written, and we have some more functions right here that we got to fill out, right? So we have some, so these are all the little variables we gave you. And here we have another function of the old Scrabble scorer and the old point structure. Now, one of the things that when you create this function, the initial prompt, you're going to have to put your initial prompt in here. You know how to do this. We've already done this, so you know how to do that. So now, one of the things I want to point out to you to see something here, we talked about parameters. Inside this function, old Scrabble scorer, we have a parameter of word. We use that as word. And you notice here on line 16, we're using it like a variable. We're storing this word right here dynamically. So that means that whatever word I pass in as an argument, like coconut or pineapple, to the old Scrabble scorer, it's going to convert, because what this function knows is that this parameter says word. And when I get ready to invoke that function, I'm going to do old Scrabble scorer, parentheses, I might console.log, old Scrabble scorer, and I might pass coconut inside of it, where it's going to go through this function and it's going to check. So this word, let's say technically this word now is coconut. And what we did was we added the 2 uppercase. So we want to change everything to uppercase. And now whatever it is now being stored in a variable word. So this word coconut now is being stored in that variable word. So now that word, this word variable now, which is the parameter, has an uppercase coconut. All the letters are uppercase. And then you notice here we got an empty string here. So whenever we have empty strings, empty object, empty arrays, or the number 0, what we're planning on doing, we are doing what? When we initialize variables with those types of data types, we're looking to pass stuff into them. We're going to use those. So that's why it's empty right now. And that's why it's going to return it on the outside. So remember, we got our function here. We got our open and curly braces on line 15 and line 30. So make sure everything stays within that function. So here's our example. Now notice something here that when we talked about the data structure of the big O notation, we have a nested for loop. This is what we call an O of n squared. This takes a lot of effort, a lot of time, because it has to iterate twice. And understand with iterations, it iterates over everything. And it keeps going until it finishes. So it doesn't just do it one time. It's doing it twice. So it's got to do every time for that word coconut. It's going to iterate over that word coconut the first time. And it's going to all be stored in the I. So it's going to go over word. All right. So the first word is C, which is true. It's at the length. So it's stored in I. And then we got const here. It got the point value. Now you create this. We gave you the name for it, but you actually create this variable right here. So this is all it is. It's a variable. And this is final. So whatever this is, it won't be immutable. It will be immutable. It will be immutable. And it's going for everything in the old point structure. So we got n. So now it's iterating over everything into this old point structure. And it's looking for that C. And so then within this same for, because now we're in this same for, because this is the outer for loop. So this is the closing curly brace, opening curly brace on 19, closing curly brace on 28. So that lets you know that this for loop is nested in this for loop. And so now we have another curly, so we got an opening curly brace for this inner for loop. And inside this inner for loop, we have a conditional. It says if O point structure, point value, this is a variable because it doesn't have the quotes around it. That includes this word right here, which is coconut, that is broken down, each one of those letters that's stored in the index of word I. And if this is true, if that's true, that letter is there, and that letter is in which we have it inside the point value, the old data structure, point value, which is stored in point value now, because all these keys and values are now stored in point value, and it's comparing. Then it says here, letters point, which is this right here, that's empty. And this is what we call an accumulator. I think it's accelerator or accumulator. I think it's called the accumulator pattern. The accumulator pattern is plus equal. How this is actually can be written another way, just so you can understand, it can be written like this. That was just a shortcut way. Look, what did I do? Make sure I didn't mess something up. This could be written like that, but this is the shortcut way. So it's like a compound. So what it's saying is letter points plus whatever this value is, which is this string, is adding the string for the word I. So it's going to go for that letter C, O, N for coconut, each letter. And then it's going to print out the point value, which is going to find which key that's in. So each one of those letters in coconut is going to also be printing out or storing. If this is true, if it's in there, as if it's included, it's going to give me it's going to have all of it is stored inside of letters, the letters, because I want to get this all stored inside this letter empty string. All of this whole string is going to be stored in there with these variables, the word index, and also the point value. And then
so the word index part it's basically saying whatever letter it's on, display that letter, and then tell us what the point value
Yes.
according to that is?
Yeah, it's gonna be a string. It's gonna print it. This whole string is gonna be stored in there. It's gonna have the points for each one of these each letter, which is the index of the word that we iterated over this first loop, and it's going to be joined to, or it's going to be brought together with this point value, which has all of these keys and all these letters, and it looks for it, and it's going to find it at this particular key, and so it's going to print out that key.
Okay.
So it's going to give us back the point value key. And then we're returning letters point, which is we want to return something. And the thing we want to return is the letter point, because that's where we're storing the information. And this is what we want to get back. This is what we want to get returned back to us. We don't want to get the word turned back to us. We want to get the letter points. So it's important to know what we're returning and where that return goes. Because once it hits that return, everything stops. This whole function is done once we hit that return. So once that's done, now this when we start, this is why you want to do your first one. So we modify the provided input initial prompt. We want to modify this function right here to prompt the user to enter a word to score. Then we want to use the old scramble score, which is up here, function. So we want to use that function right here. So we want to get that function right there. And it says, provide to score the word provided by the user, print the results to the console. So here we, let me see, we're going to add to, what did it say? Old Scrabble score. So we want to add the old Scrabble score. So we want to be able to prompt the user when they store that word. We want to get the old, because we have it inside the word, old Scrabble scorer, and it's already there. And so all we want to do is we want to get that old, print that old, it says use the old Scrabble function provided to score the words provided by the user, print the results to the console. So we probably want to add it down here into the run program, because we want to be able to run that piece of the program, right? So we want to run that piece of the program, and then this is how the results. So that right here, we got that points for, here it is right here. Points for, that's going to all be stored in the letter points that's being returned. So if I use pineapple as an example, it's going to print out the string, because we made it a string, because see, we put it inside the quote right there. Inside the quote, the word variable with the I. So it's going to print out the letter that we iterated over in the for loop, and then it's going to add each one of the keys to the number. So that's all this point value is doing, is getting the keys for us. And it looks for the value inside the key. So that's your first A. You're doing A. And so then when you get down here to B, add and organize your scoring algorithm, it says, now we're going to get down here to these variables that we created for you. We got the simple score and the val bonus score. And so we're going to take these two variables. These are here. It says simple score, define a function, simple score. So we're going to define a function that takes a word as a parameter and returns the numerical score for each letter within the word is worth 1 point. And so we want to make that case insensitive as well. So we already got the examples up here. It shows, we gave you some examples inside this function. Now, one of the things you may think about, and if you decide you want to make this even better, if you find yourself kind of writing some of the same stuff, pay attention to make sure you don't need a helper function. That's for later on. Just follow the instructions. But if you want to do some refactoring and start playing around with the code, how can you make it more efficient? That's a good way to try to figure it out. Now, can we make this more efficient right here? Possibly there's a way when you're dealing with data structure, but it's when you start dealing with pointers and stuff like that. That's a whole totally different algorithm. Dealing with a pointer and pointing and storing everything into a hash table, because we can store stuff in a hash table, and they can make your time and space complexity better by using hash table algorithm. But that's more advanced to do that. So right there, just go through each step. You got point A, point B, and keep running until you keep testing it to make sure you're getting the right outputs before you go too far. Before you go to C, make sure you're getting that output. So we went through it, we talked to it, and go and do some research on, make sure you understand functions, understand objects. Like I was saying about the objects, you can change the value of an object, like these keys right here. So I have in this old point structure, I can change that key to just be a number. It don't even have to be an array, because I got const right there. I can go ahead and change the value of each one of those keys. So that const doesn't mean the values of the keys. It's just that it means this variable right here in memory cannot be changed.
Okay.
All right, awesome. Man. Any questions?
Appreciate it.
All right, you are welcome. All right.
No questions yet. I'll reach out. I think that I'm going to try and play around with it. I tried to do much of this yesterday and I ran into an error, and so I was like, well, let's meet and talk through it, go through it step by step again. So
go through it step by step and figure it out. And like I say, we'll when is this assignment due? Let me go and stop this video, stop recording, because we're done with this. I don't know what I just did. Okay, let me stop sharing. All right, let me see where this. I hope this. Okay, let me stop recording.